Hi everyone, so today we are going to present our project which is Euler cycle. So let's restart. Hi, my name is Nur Yasmin binti Norman. My metric number is 224095.
Hi, my name is Nurul Amani binti Muhammad Azmi and my matrix number is 224624.
So we are going to our introduction. Do you know what is Euler cycle? Do you know Euler cycle have two different things, which is Euler circuit and Euler path. The first one is Euler circuit. What is Euler circuit? Euler circuit is a connected multigraph, which is all the edges in the same graph are going through exactly once. The second one is Euler path. Euler path is also connected multigraph, but it will start and end with the same vertex, and it will travel passing through all the edges.
Okay, next for theorem of Euler circuit. The statement is the connected graph has an Eulerian circuit if and only if every vertex in the graph has an even degree. The key condition is that all vertices in the graph must have an even degree for such a circuit to exist. For example, I'm gonna make a graph here. Okay, so in this graph, each of the vertex has odd degrees. Hence, this graph is an Euler circuit.
The next one is Euler path theorem. The statement is a connected graph has an Euler path but not an Eulerian circuit if and only if it has exactly two vertices with an odd degree. So for the example, 4 vertices and the path is look like this. It has a 3 degree, this is have 2 degree, this is 3 degree, and this is 2 degree. So there is the 2 vertices that has the odd degree. This is the Euler path.
Okay, so for Euler circuit is the path that starts and ends at the same vertex, visiting every edge of the graph exactly once. And every vertex in the graph must have an even degree, where the degree of the vertex is number of edges incident to it. A graph will contain an Euler
So
circuit
let's
if
we
all
do for the
vertices
first
have even
examples of Euler circuit. As I said, that we must identify the degree, which is it has odd or even. So let's recalculate the degree of this diagram. This is have a 2 degree, 4 degree, 2 degree, 4 degree, 2 and 4 degree. So we can see that all the degree is have a even degree. So yeah, this is an Euler circuit. The second step is we need to make sure that the starts and the end points at the same vertices. So let's redo it. For example, we start from A. A are going to be B, C, C, A, E, E, C, C, D, D, E, E, F, and the last one F, A. You can see that the starts and end points at the same vertices, which is A. So yeah, this is an Euler circuit.
Okay, for another example, as usual, we need to find the degree first. If this graph has odd degrees or only even degrees, to identify if it's an Euler path or Euler circuit. So we can take a look at this graph. So A has 2 degrees, B 2 degrees, E 4 degrees, F 4 degrees, C 2 degrees, D 2 degrees. Hence, all of the vertex has degrees. So this is an Euler circuit. So for the next step, an Euler circuit must start n ends at the same vertex. Therefore, you can look at the graph here. We're going to start with E to A to B, B to F, F to E to F back, F to D, D to C, C to E. So the graph starts with E and ends with E. So it is an Euler circuit.
The next example is, as usual, we need to identify the degree which is even or odd degree. So let's restart. This is have 2, 4, 4, 2, 4 and 4 degree. So as we can see, all the degree is even. So yeah, this is the graph does have an Euler circuit. The second step is we need to identify and make sure the starts and end points at the same vertices. So we start from C to B, B to E, E to D, D to C, CE, EF, FD, DB, BA and back to C. So yeah, this is literally start from C and end to C also. So yeah, this is an Euler circuit. It does have an Euler circuit.
So for Euler path, the graph must have at most 2 vertices with an odd degree.
For the examples of Euler path,
have an even degree.
yes, let's restart. The first thing we need to make sure at most the graph is only 2 vertices of odd degree. So this is have 1, 2 degree, 2 degree, 3 degree and 2 degree. As we can see, there's have a 1, 2, 3 even degree and 1, 2 odd degree. So this is an Euler path because this is have 2 odd degree at vertices. So yeah, this does have an Euler path. The second step, we need to identify the Euler path. So we start from 0, 0, 1, 1, 4, 4, 3, 3, 2, 2, 4. 0, 1, 4, 3, 2 and 4.
Okay, so for the next example, as usual, we're gonna need to find the degree first, if it has odd degree or only even degree. So in this graph, we can see A has 3 degrees, B 3 degrees, C 3, D 3 and E has 4. So as you all know, for Euler circuit, so for Euler circuit, you're gonna need all vertex has even degrees. And for Euler path, you must have at most 2 odd degrees and the rest are even. in this case, we have 4 odd degrees. Hence, and in this graph, we have 4 odd degrees and 1 even degree. Hence, it is nor Euler circuit or Euler path. So for next question, what is this graph gonna be? Is it an Euler path or an Euler circuit? So as usual, we're gonna need to find the degree first. Is it has odd degrees or only even degrees? So as you can see in this graph, A has 2 degrees, B has 3 degrees, D has 3 degrees, and C has 2 degrees. So as you all know, an Euler path must have at most 2 odd degrees. Hence, this graph is an Euler path. So how are we going to prove if this graph is an Euler path? As you all know, there's no need for an Euler path to start and end at the same vertex. It can be different. So we're going to start with D to C, C to B, B to A to D, and lastly D to B. So this graph shown that there is an Euler path.
Let's be finding an Euler circuit or Euler path. Let's do it. We must find the degree. So this is have 1, 2, 3, 2, 4, 2, and 3. As we can see, there's have a 2 odd degree and 3 even degree. So yeah, this is an Euler path. The next one, we must search the way of the Euler path. Euler path. We start from B, B, E, E, D, D, B, B, A, A, D, D, C, C, A. So yeah, B to E, E to D, D to B, B to A, D, D, C, C, A.
So we're gonna put labels here in this graph to make it easier to understand. B, C, D, E, F, G, H, I, J, K, L. So as usual, we're gonna need to find the degree first. If it has odd or even degrees. We're going to count it now. A has 2 degrees, B has 4, C 2, D 4, E 4, F 4, G 4, H 4, I 4, L 2, K 4, sorry, and J has 2 degrees. So we all know that in Euler circuit, the vertex must all even degrees. So as we all know, a vertex that has all even degrees is an Euler circuit. So to prove that this graph is an Euler circuit, we're gonna make a path. So from F to A to B, B to C, C to I to L, L to K, K to J, J to F, F to D, D to B, B to E, E to I to H, H to K, K to G, G to D, D to E, E to H, H to G, and G to F. So the graph starts with F and ends with F. So it is shown that this graph has an Euler circuit. So we are at our last question already. So is this graph going to be an Euler path or Euler circuit? We're going to find that now. So as usual, we're going to need to find the degree, if it has odd or only even degree. So take a look at this graph where 2 has 5 degrees, 4 has 4 degrees, 6 3 degrees, 5 2 degrees, 3 6, 1 3. So there are 3 odd degrees where and the rest are even degrees, another 3. So as we all know, the key for Euler path is it must has at most 2 odd degrees. And the key for Euler circuit is all even degrees. So since this graph has 3 odd degrees and 3 even degrees, this graph is nor an Euler path or Euler circuit. So that's all for this Euler cycle.